Good morning. Thank you everyone for joining. My name is Ariel. I'm co-founder, CEO here at CoreLogics. The interesting parts will come after me. I'll just give a quick overview of what we're here to look at today. CoreLogics was founded about 10 years ago, and we started a journey of completing what we call today full stack observability. So everyone in our space are talking about a single pane of glass. We learned that to actually have a single pane of glass, we really need to correlate the data together on a single query, on a single panel of dashboard, on a single alert. And to do that, CoreLogics developed two main engines. One is the DataPrime engine, which allows us to, first of all, structure data to your own storage. That could be GCP storage, that could be S3, that could be IBM Cloud Storage. And then query that data directly from CoreLogics, no matter the data type. That could be logs, metrics, traces, real user monitoring, SIM, all from the same source. Now, Streama is the real-time streaming engine that we built that allows us to then get all that data in, do all the data transformations that we want, all the detections, including alerts, machine learning models that we run, and then route the data to whatever destination that you guys pick. What that allows us is to run one DataPrime query on logs, metrics, traces, RUM, even do joins between the different data types, have a single panel of dashboard having multiple data types in it. So for instance, you could look at the correlation of memory and errors and latency and user experience, and then have a single alert that has all data types lined up at a sequence, what we call in CoreLogics flow alert. So you could say, did CPU affect my exceptions in app that affected the customer failures on the front end? That is the purpose of this meetup, is to get you guys more efficient and more professional with DataPrime. The idea is to look at, first of all, the concepts and what DataPrime brings, then a bit more on the practical side of examples of a few ways that we can actually bring business value into our customers and into our company from the observability data. Remember, observability data is the largest source, highest volume, most real-time, highest dimensional data that you have in your organization. It just makes a lot more sense to use it way broadly than just fixing issues or finding bugs. The idea is to power up decision-making within the business. So we'll see a few examples to that. And then go to what we call the art of possible with DataPrime. The possibilities that you can run with this language. It's a declarative language that can actually allow you to do anything on your data. And we want to show a few very interesting examples on how we take data that is not the most hygiene, not the most parsed, not the most organized, and turn it into actual powerful business insights. The power of taking any log, metric, trace, RUM data, SIM data, and structuring it, then breaking it down, then running schema on read, then joining it with other data types and enriching it on the fly, means that you can build your business. APM views that match your business goals. So not anymore, red metrics, app deck scores, things that are present. But now we're looking at what is the performance that a particular service is providing to my clients, and what is the business impact of it? How does that match what we aspire for? And I think we'll show a few examples on how CoreLogics does that today to track your queries, to track your NPS, to track your user experience. And this is the knowledge that we want to transfer to you guys so you'll become more efficient. Just a bit about the company. We founded 2015, launched 2017, raised about $350 million so far, running multi-region on cloud, multi-cloud, including the GovCloud, by the way, regions all the way from Asia, Europe, US, East and West. And we're serving over 2,000 accounts today. These are just some of them, but different industries, sizes, geographies. And we also have offices in Tel Aviv, London, Gurgaon in India, Boston, and the Bay Area in the US. So wherever you are, we're local to you and we can serve you directly from your region. Thank you very much, and I'll hand it over. One.
right. Good morning, everyone. Welcome to this event. Welcome to Unlocking the Power of DataPrime. So this is me. My name is Moran Talbi. I invested the recent 15 plus years in the tech industry. I'm a technical account manager in CoreLogics. The recent 8 years, I invested in enabling engineers on next-gen platforms. I would call myself an observability enthusiast and a DataPrime fan. So this is our agenda for today. So this day, like Ariel said, is obviously about DataPrime. We're going to start off by defining what DataPrime is. We do some high-level introduction to the language, to the engine, and how it helps you transform observability data into actionable intelligence. Then we move on to intro the main concepts of the language, like structure, syntax, and also the logics that drive DataPrime capabilities. We're also going to touch the AI assistant, which helps to enable users on DataPrime. How DataPrime powers CoreLogics, we're going to drill down to some real-world use cases. I'm going to showcase some real cool stuff. And we're also going to speak about the platform and how DataPrime is integrated in CoreLogics. Eventually, what we call dog fooding, we're going to see how we in CoreLogics monitor ourselves. I think this is one of the most interesting parts of this session, and I'm going to explore some real-world use cases. We're going also to uncover how we track user query performance for optimization and reliability. So that's what we're going to cover. So why not just starting with defining what DataPrime is all about. So DataPrime is CoreLogics' proprietary query language. It's actually named after a very powerful next generation engine that we built here in CoreLogics for deep observability and real-time insights. So throughout this session and throughout this day, we're going to reveal and uncover the true power of this language and engine. So I really like to start with a small challenge. For any of you who's already familiar and gained some hands-on experience with DataPrime, it's not a real challenge. But to any of you who's completely new to the platform or to DataPrime, this is going to be quite challenging. And I'd like you to think about how would you filter logs where field A matches field B, dynamically, of course. So this task is a very simple one, right? Super straightforward. But how would you do it in CoreLogics if you're not using DataPrime? So in CoreLogics, you have Lucene, for instance. Let me tell you that with this search engine, like Lucene, it's simply impossible. And with DataPrime, these tasks is extremely simple and straightforward. And this is how this would look in DataPrime. Filter field A equals field B. Now, the reason why I wanted to show you this is not because I wanted to expose some DataPrime muscles or to run some comparison between one language to another and telling you what one language can do and the other one cannot. It's not even matched. But the reason is that I wanted to drive a thinking in you about other things that you're not exposed to and you're not even aware exist, or you're not even aware that you cannot do. And if this super simple task is not achievable with what you have today with your querying language, then what other things cool and complex cannot be achieved. But it's not only about this. it's also about this. It's a whole different game, a whole different world. We're speaking about searching versus analytics. While searching is actually something that you do to expose, to uncover the known unknowns, right? So you know what you're going to search. You know that the problem occurred. You know there was some chain of events, an incident that was triggered some alerts, and then we start searching. But this is us being extremely reactive to events. While analytics, which is one of the true powers in DataPrime, is a different game. We're speaking about exposing not only the raw data, not just searching in the raw data, but also exposing the metadata and figuring out how the metadata on the data looks like and acting, and what's the trends. And this is powerful, and this is a game changer. Now, you know, sometimes we get really excited when our observability platform provides us some out-of-the-box insights, right? And pre-made packages. We have them in CoreLogics as well. They call extensions, and they're really cool. And I'm not saying they are not cool and handy. But you know, I would allow myself to borrow Ariel, the CEO's example or metaphor. It's like walking into a Photoshop, right? Not the software, but a real Photoshop, and looking to buy a frame. Now, you know, when you're buying a frame, it comes with like a mock-up family picture, right? It is not your family, but it's some family. And it's on you to pick up the frame and place your true family's picture into it. And this is exactly what we believe, and what I personally believe the true power of an observability platform. It's the freedom it gives its users to treat a raw data like it was a Play-Doh. And this is what you are capable of achieving with DataPrime. Right? So the greatest thing about it is the ability to manipulate your data, but without changing it. And this is great. So things that until now were only possible with some super admin capabilities or super admin permissions are now enabled for any standard user, read-only user. You can do everything. And this is very cool. So here are some of the core advantages and things that you can achieve with DataPrime. So first, it's seamlessly integrated with the CoreLogics core engine, which is a great advantage for any user. It's available in both frequent search and all logs. So it doesn't matter in which tier your data lies in CoreLogics, it's still accessible and can be parsed with DataPrime. A real-time data processing. Like mentioned a minute ago, no role-based limits. So it doesn't matter what is your role in CoreLogics. You don't have to pick up the phone or send an email to your CoreLogics admin for some parsing or enrichment. Everything is available in the language. Works seamlessly with logs and spans. So if any of you using spans and logs, or at least one of them in CoreLogics, DataPrime can parse these type of data. And in one of the examples I'm going to showcase later, you will see how we can combine in a single query logs and spans. And this is awesome, and it's extremely valuable. And optimized for building custom visualizations. So guys, this is not only to parse and generate like the old-fashioned JSONs. You can create amazing visualizations with those queries, and we're also going to see later some examples. several concepts that the language and the engine supports. Starting with filtering, which is the most basic, and we started with this little challenge, but the language enables you to do a much more complex filtering. Extraction. So extract is extremely important and cool capability because you can restructure your data, right? You are a standard user, maybe a read-only user, but you can restructure your data. You can extract from a raw message and index a new field and then see analytics on it. How cool is that? And again, it's available to anyone because you're not actually changing the underlying raw data. Aggregation. From simple aggregations such as count and sum and max to much complex aggregations like count if or percentiles that we're going to see later. This is available for you, and also transform. The idea behind transform is that you can, again, play your data, your raw data, like a jelly, Play-Doh or clay or whatever, and you can create new fields that were never there before and populate them with any data that you like. You can modify data using functions and do things dynamically. And eventually calculations. So any mathematics that you like to do, create formulas, turn your logs into matrices and use them for calculations. We talked about metadata. So everything can be done with calculations, and all of this is supported. It's important to say and important to understand that if you control these concepts and few building blocks that enabled by the platform, then you can almost achieve anything, right? Any challenge that you have with your data. Let's cover this query structure. It's extremely simple. This is a standard structure of a query, of a DataPrime query, starting with declaration of the wanted source, whether it's logs, spans, or custom. Custom can be like custom CSV that can be used as index, and then you can enrich your data, your logs or spans in real time. Starting a new line with a pipe, and eventually add comments by using hash. So this is a standard structure. Let's uncover the key path access. So in DataPrime, we have three types of data, starting from the data itself for accessing log-related JSON keys. So we have the $D or $data. I'll tell you a secret. When you are writing a query, you not explicitly need to use it. Writing a message or log or host or whatever the key name you like to access without the $D would work just fine, but maybe for readability or for any other reasons you can use this. Then we have the metadata. Metadata is generated by CoreLogics and can be accessed with the $M or $metadata, it's just the same. So we have a timestamp, severity, log ID, priority class, which actually tells you if your log is high, medium, or low, frequent search, monitoring, or compliance. Ingress timestamp, right? So think about writing a simple query that do the calculations, calculating the delta between the timestamp and the ingress timestamp, and then you can track any meaningful lagging in your data. Template ID, anyone who using templates in CoreLogics, so template ID is available from $M template ID and branch ID. $L for labels. We have several labels available in CoreLogics. The top two are the most common one, which I'm pretty certain that you guys are familiar with. The application name and the subsystem name can be accessed with the $L. And they're usually used as placeholders for the environment or the service or a subservice. And computer name and category, which are also part of the tags or labels that you as customers sending to CoreLogics with each and every log, but those are less common, so I mostly like you to remember the top two. So this is how we access data with DataPrime. We see it on later examples. Some orientation. Okay, so this is your explore screen in CoreLogics. So right here on the right, you have the in-app comment reference, which is this tooltip with the question mark. And it's actually a thin cheat sheet including everything you need, covers all the functions and the commands with real-life examples, so it's very easy to use. Then you have the query itself. The DataPrime query goes here. The query result. I like you to notice that this result is probably different than what you used to with, for instance, Lucene, right? It's a table, it's not a JSON. And it is very cool because we can aggregate and group by, and then we can see trends and not only raw data. And Eyal Shainis, that will follow this session, will show you amazing examples. So this is just a very simple one. And on the top right, Query Assistant, the purple button that I will also cover later in some examples. Custom dashboards. So if you're using CoreLogics custom dashboards, our visualizations, proprietary visualization engine, so DataPrime widget is available there, meaning that you can turn your queries, any query, into visualization, in this case, to a line chart. And if you're not familiar with the language, that's just fine. But please notice that we're grouping by a timestamp, dividing by 10 minutes. So we are actually creating time buckets within the language, within the query. And this is translated into a line chart. But we can we can create and design any visualization, any widget that we like using DataPrime. And we can also see side by side the raw data and the query and the visualization. So this is how it looks in CoreLogics custom dashboards. Let's speak AI. Okay, CoreLogics started to heavily invest in AI. One of the first things that we came out with was the AI assistant for DataPrime. The AI assistant for DataPrime allow you to write a natural language query, and it will be translated into a proper DataPrime query. And this is just one example how we asked. I know it's a little small, so let me read it out for you. Tell me the top 10 IP addresses by count, right? And this is what we get. First, we get the query itself, then we get the list after running the query. Now, there is something that is missed here. You see the first line is null. And this is because the AI actually kind of missed it. Okay, it happens. But this is why you are required to know something about the language so you can adjust it later. I always say that AI can take you from 0 to 50, 60, 70, never from 0 to 100, at least in nowadays. So in this case, why we see null here as a top result? Because we didn't filter logs, only logs where this IP field exists in. Okay? The AI missed it because we didn't explicitly ask for it. So it's like a mistake. It's not a real mistake, but something that we can take care of really easy. Another example for the AI. So this was the task. Create a report of HTTP response sorted by count. And then what we asked the AI query assistant, aggregate and count HTTP responses for the front-end service and sort by count. And this is the query we got. Now, to any of you who's not familiar with DataPrime, That's fine. This is a proper English, right? We are filtering by subsystems equals front end, then we're grouping by the response status. We ask to aggregate by count. We do some alias, response count, and then we order by it, okay? And this is just a proper DataPrime query that was generated by the AI. How cool is that? I think it's very cool. And the AI is great to enable you on the language. So if you're just starting with DataPrime, so start with simple tasks. Start with define simple things to the AI and see how the query is structured, learn about the basics, and continue from there. Another example of using the AI, this time going from natural language all the way to this visualization, okay, this chart. And you can see that in this case, we asked the AI, show me a graph of the top 20 IP addresses, and we got something like this. Naturally, these requirements, these tasks we gave the AI are extremely basic. I can give you first-hand testimony that I was privileged to work with the AI assistant many times on many use cases, and it can handle way complex scenarios than this. But to start off, maybe it's a good idea to start with simple things. So, you know, this is something that I always or commonly hear from users. I'm good with the basic querying language that I have. In CoreLogics, it could be Lucene. It gets the job done. And I'm not arguing this statement, and I'm not going to convince anyone about what's good for them. But what I really like to do is to show you some of the most powerful commands we have in DataPrime. I picked up 3, and I want to show you these examples one by one. Now, the idea is not to teach you DataPrime here and tell you what each one does exactly line by line, but to show you the capabilities. So I like to start with join. Now, I believe that this audience is made out of developers, right? Also people at home, online. Join is a common thing. By the way, in CoreLogics, in DataPrime, we support join, full join, inner join, all types of join. DataPrime supported, but let's look at a simple basic join that can merge the current left query with the second right query based on a condition. This is an example of such a query. The idea that I really wanted to bring here is, look at the source in line 1. The source is logs. Look at the source in line 5. The source is spans. So we are actually working at the same time, simultaneously in the same query. We're covering 2 different types of sources, logs and spans. And the result look like this. We actually get trace IDs. If you're not familiar with the concept of tracing and spans, yeah. So span is the smallest unit, logic unit in a trace. A trace actually represents a journey of a request end to end, okay? From when the user clicked something on the screen all the way to the database and back. Okay, so this is a trace made out of smaller units called spans. The calls between the services, and also span could be internal into a service. So a trace ID represents a trace, a request end to end. So here we got the number of logs correlated with this trace and comparison with the number of spans. Now the use case itself might not be super common or valuable, but the idea that you can actually combine few things, few sources into one and get insights which are very relevant for you from different words in a single query is pretty amazing. By the way, in dog fooding, we can showcase that in Coralogics, we use exactly the same technique to see in the single line the trace ID, the performance, let's say, in milliseconds, who the user who ran this query, and also some insights coming from the logs. And then we have a full picture of who did, how it reflected in the logs, how it reflected in the spans in a single pane of glass, and this is awesome.
Such query can be generated by the AI assistant?
Yes.
Okay.
Yeah, you can. The question was if we can generate something like this with the AI. The answer is yes. With all the limitations of today's AI, you need to be precise. You need to know how to phrase what you want the AI to do for you, etc. Okay. The second example, the second command is extract. So I mentioned it earlier. If until today you were required to pick up the phone or to send an email to your Coralogics admin and beg or at least ask nicely for them to do some expensive parse rule, expensive not because Coralogics is charging for parsing rules, but because it's expensive to create one, because it's not something that any user can do in the system. So today you have the power in your hands. And extraction looks like this. So look at this message. This message contains some transaction ID inside it. It's just a text. But what I really like to achieve here is to extract the transaction ID from my message into a separated field so I can actually see trends and do analytics. You remember search versus analytics? I can analyze how transaction IDs behave in a given period of time. And this is already how my query would look like. And look at the regex. Look at the regular expression here in line 3, which is actually the extract command. I'm ordering to extract from message into $D, which is the root level of the log, using a regular expression that actually identifying the transaction ID colon and extracting the value, the actual ID, into a separate field. Now look at the result. Message was left untouched. I can later on remove it or do whatever I like with it, like a Play-Doh, remember? But the transaction ID was extracted and indexed into a separate field. Now I can do show graph for key, group graph for this key, and learn about the trends and create alerts. Okay, just 1 second. We will have time for questions right at the end, which is very near, by the way. Okay, so this is about transaction ID, and eventually enrich. Enrich in Coralogics, in DataPrime, is the ability to dynamically add context to existing raw data based on some, let's say, CSV that you can upload. I chose something very simple and straightforward, like keeping it simple, stupid. HTTP status code. So I uploaded an index, a map, that mapping status codes to their related text. 100 is continue, 200 is OK, and imagine that you have the entire list there. Now I have run this query. I created this query that, using enrich command, to enrich the status code field using, I call it status code for training. Okay, this is the CSV that we just saw. And this is already the log itself, the log, or actually part of the log. The log contains more context now. I created a status enriched sub-JSON, and the status code was 401 in this case, and it got the unauthorized text next to it. Now, it's not only that, but as a next step, I decided to group by. Okay, it's not only that I added context and I got it as a JSON. This is nice, but I want to take it one step further and actually group by my new field, and this is what I get. This is a new dimension that wasn't exist, status. Okay, so this is very cool. So just going one slide back. Yeah, and I also added the error count, byte sent, so I get way more context while analyzing something. And again, this is the basic of the basics. Imagine that you can enrich with anything, with region, site, more context about your users, more context about the services, the servers, you name it. I just wanted to keep it very simple, just for the sake of the example, but and delivering the idea behind it. So now to the last part of this session, dog fooding, or in other words, how monitoring CoreLogix with CoreLogix. So I'm going to show you something that we do. We always say that we are our best customers. I worked for companies which it wasn't the case, but here, believe me, we are heavy CoreLogix users and DataPrime users. We do it every day. And the first example I like to share with you from our day-to-day is this: query data scanned per time range in gigabytes. Now, you as CoreLogix users are running queries all the time. And we like to monitor the performance of these queries and the user experience that you get by when using CoreLogix. So using DataPrime, we did this. We created, it's by the way, a single widget, single panel out of a full dashboard with so many things. But I picked up this one, and you see here on the left, I know it's a bit small, so let me read it for you. Query time range, and you can see less than 5 minutes, less than 15, less than 1 hour, etc. These buckets were created dynamically with CoreLogix, with DataPrime. And I could manipulate it and adjust it to my needs. I have a customer who told me I like to see performance for any query under 1 day, any query under 3 days, any query under 1 week. Okay, I'm speaking about the window interval when you're using the time picker. Okay, so these user ran their queries on last 5 minutes, and this user ran their query on recent 72 hours. And then we have percentiles. We have query counts, how many queries were ran by the users. I believe this is for, I don't know, 3 days or so. And then we have percentiles. Okay, remember aggregation? We created percentiles, P50, 75, 90 max of data scan. We can see the trends of data scans by percentiles per these buckets. Okay, so for instance, for 24 hours, last 24 hours, the P50 of data scanned was 0.0294 gigabytes. And this is very cool, and it helps us to be one step ahead of anything regarding performance. And it helps us to be transparent with our users and customers when they come to us and say, hey, I experienced a terrible performance. I can filter this table by a specific customer, sometimes even by a specific user, and see exactly what performance they got. Also in milliseconds, by the way, not only in gigabytes. And this is already a visualization showing the query max data scan per time range. So from this fancy table, I left 2 columns. One is the buckets, 30 minutes, 15 minutes, etc., of the window interval of the query, and the max. the maximum. So you can see very clearly that above 1,000 gigabytes, 1 terabyte of data was scanned in average for above 72 hours queries, which makes sense. While for, I don't know, 6 hours, it was 690 gigabytes. So I can create cool visualizations with this as well. So this is us. We do a lot more with the platform, with our own platform, and particularly with DataPrime. And we would love to share with any of you best practices from our experience on our own platform. And I'd like to thank you for listening. And now I believe we move to questions. First, we have questions right here. So.
First of all, thank you. Hi. Just a quick question regarding the AI capabilities, regarding like the text to DataPrime's text to basically to query language. I was wondering, since we know our data, let's say as a customer, I know my data, and as I saw, like there is situations where the AI might not be as accurate as I wish. So I was wondering, do I have also the ability to fine-tune or like have more context, add more context to CoreLogics? So next time I might ask a similar question, the AI will most likely be more accurate.
Thanks for the question. So AI questions, I mean, I'm not the AI expert in CoreLogics, but I can tell you that we are one step before keeping a context, like you have in GPT, for instance. So he already know about you and what you're doing, and then it retains some context and can help you further. At this point in time, each AI request is a standalone request, okay? So you can ask whatever you like, generate queries, adjust them, and do it again. But we are getting there, okay? We are getting there.
I want to add one more thing about this. This is one thing, like a chat-based longer context, but we are also working in parallel on providing some, I need to talk to this one. We are also we're working on a flow-based, like a chat-based interface as well, but we are also working on being able to provide customer-level context, which is generic, like things that are obviously custom to your own needs as a customer, like my important fields, etc., like things that I think that what you were referring to. We are working on providing as if it's like a system prompt for on a per customer basis. So all the next AI questions would actually pave the way. The system will be more educated in terms of actually touching the things that you as a customer, the things that you most care about.
Who else had a question?
Hi. Regarding the enrich capability, how can do I have to upload CSV before using it? How can I do it?
Yeah, so the question to anyone who missed it was about the enrichment capabilities and how to upload the CSV. So uploading the CSV would require some elevated permissions. I mean, it's just for the uploading itself because you're actually adding some data to the system, so obviously it requires some elevated permissions. But yeah, after you get your CSV prepared, it can be not just, it's not limited to 2 columns or anything. You can do whatever you like. And by the left column in your CSV, this is how we do the matching. So in my left column, you had the status code, and this is what DataPrime will look the match. Okay, so long story short, yes, you need to upload a CSV. You need, if you're not a system admin in CoreLogics, you will get it prepared, you get it ready, and then your admin or anyone with the right permissions would just upload it. It's a 1-second thing.
I actually have a few questions. Let's start from simple ones. The queries itself, can I save it for future use in UI?
The query?
Yes.
Yeah. So the question was whether you can save queries for later usage. The answer is yes. You can do it with saved views. Okay, we have this option to save views and save queries and filters. So you can actually save queries.
Cool. And additional question, it's in regards to the logs itself. When I use it with enrichment or extract or different functions, does it change the logs itself, or it's just affects the representation of the output of the query?
Yeah. So if you recall in one of the first slides, I mentioned that we're manipulating the data without changing the underlying raw data. And this is why you don't have to be an admin, a CoreLogix admin, in order to do extract or enrich or whatever. You have the power as a standard user, a read-only user, to do whatever you like without changing the data.
Okay. DataPrime, can I use it in alerts engine or only logs?
Okay, important question. I'm glad that Harel, our chief architect, is here. Not just yet, but it's coming very, very soon. The question was about enabling DataPrime in alerting.
Yes, we are actively working. I'll talk to you about it in the next session I have.
So
Actively working on
And
it will be covered in the next session.
My last questions in regards to AI capabilities. I would like to understand how you use our data. Because we have some kinds of data that may be sensitive, and we would like to know that it's not you not learn your AI system based on our data, or not use it in our system.
So it's a mostly compliance and security question about how we use AI. I will leave it to Harel and also to our legal department. Very good questions. We have all the documentation and the information to share with you offline. Okay, I mean it's.
I can say a word about that because it's an important point. None of our training is happening on any of the customer data. We devise a few training methods that are based on our own internal CoreLogix dog fooding and additional metadata and general context from other sources, public ones of course. No private data that's being used in any of them.
Yeah, so I hope that answered the question. We're not training any data on your, based on your raw data. So thank you everyone, thanks for the question, thanks for listening, and I'm handing it over.
So, hey everyone, my name is Eyal Shainis. Once we've got the basic things about DataPrime, I want to show you some examples of how using DataPrime can work in the platform. So let's reset it. This is my demo account, which is an e-commerce account generating false demo data. And we want to work on this data in order to get some insight, right? We talked about the difference between searching data and viewing data and analyzing data. So for example, when I want to look at data, I'll start with a simple source logs, right? So source logs will give me my logs. Simple as that, okay? Now I can do additional things. So I can say I want to filter, cool. And I want to have a trace ID. Cool. So I'll use trace ID not equal null. Now I'll see only logs that has trace ID within them. Cool. Amazing. Let's take it to 2 hours. Okay. And wait. Let's reset it. Yeah. Start from scratch. Logs, DataPrime, all logs. Note that I'm browsing and searching my bucket and not my index data. Cool. So again, source logs,
and I want to filter that the trace ID exists, right? So JSON trace ID is not equal null. Cool. Now I want to do another things. So I want to group by. We saw the group by example, so I want to group by the trace ID. So the group by the trace ID, the JSON trace ID, and I want to aggregate it. But before what? I will rename it. So I will call the new field trace, and I will aggregate it to see how many logs I have. Count, sorry, typo, count as logs. Cool. So I now change my data. Now I have only 2 keys, which were never existed in the original logs, right? I have a trace, which was the JSON trace ID, and I have the number of logs for each trace ID. Cool, so I have a context of my logs just on APM data. Now I want to correlate it with spans, obviously, right? Full stack observability, we want to have data from spans as well. So I will do a join, right? And now I'll do a source spans. Source spans, sorry. And let's do here another group by. So group by the trace ID. I want to call it the same name as trace, right? As trace, okay? And now I want to aggregate, same aggregation, but here I will do count as spans. And I would join them using trace, into APM, right? So now my query would look that. So I have my original trace. I have the corresponding trace ID from the traces. I have the number of logs, and I have the number of spans, right? Amazing. Now I can filter. So I want to see, for example, you know what I can do? It's too complicated. I want to remove fields. So now I want to choose my important fields. So I want to have the trace ID, obviously once. I don't have it. I need to have it twice. I want the logs, and I want the APM spans as spans. Amazing. That's my data set. And I want to do another calculation. So you know what? I want to know what is the ratio between the logs and the spans. So I can create another field, and I want to create a field called percentile, right? PCT, from, and I'll do a round of logs divided by spans, right? And I want to have 2 fields. You know what? Let's multiply it by 100 because we want a percentile. So let's do 100 times. So now I have logs, I have spans, and I also have percentile, okay? And I can order it by whatever means I need. So I can do an order by, you know what, let's do by spans, descending, sorry. Right? So now it's filtered by the amount of spans. So this trace ID had 161 spans, 167 logs, and the ratio was more logs than the traces. Now I have that trace ID and can go into the APM and look at a specific trace, go over it, and so on, right? It helped me funnel my data in order to get the data that I need for my investigation, right? That's one example. The other one, so for example, I want to do, and let's clear that, and let's, in order for the sake of this, someone asked if I can save them, then yes, you can. This is another query, right? So I kept that in advance, yes.
Can I use it in a custom dashboard?
Yes. The question was, can I use it in custom dashboard? Yes, and I'll show it in a minute. This is another example, right? So in this case, note that I've ignored my original time frame here of 24 hours, forcing my query to run over the last 6 hours, right? I can do even a time shift. So I can do a time shift and look at other data sources or other data frames. So here I'm looking at last 6 hours, I want to group by the application name as application, another rename, right? My subsystem is subsystem, another rename, and then I'm aggregating. So I want to count everything as logs, right? So I want to know how many logs do I have. And I want to do a count if. So if my severity is above info, and note that severity is a numeric value, but we have the contextual data. So I'm saying info without, it's not a real string. As high severity logs. Amazing. So now I have, in this case, and if I'll filter out anything else, and that's another cool example that I can do with DataPrime, is commenting out part of the query in order to get value, right? So I'll comment out these 3 lines just to show you what will be the output. So again, the output will be the name of the application name, the name of application name, subsystem name, amount of logs, and amount of high severity logs. So when I enable this new filter and know that this filter is not on the original data, but on the generated data, right? I want to see only application and subsystem that has error logs or warnings or high severity logs, right? And now, this is the cool stuff, I'm creating the percentiles of high severity logs out of all logs, right? And I'm formatting it as percentile, right? So here, I'm formatting it so I'm rounding up the number of high severity logs out of logs times 100 to digits, and I'm adding the percentile. So here I'll have the percentile, right, as part of the calculation. And now if I want to be really cool, then I can order it by the number of high severity logs, which means get me the high generating high severity logs here on the top one, right? So I'll see the most error generating application and subsystem. I'll see how many logs, and I'll see how much. So although this is the most errored application and subsystem, the ratio is pretty low. This is the second best, but it's 37%, right? So I have context on the data. Again, not just counting. Bring me value. Another cool example. Let's go to this one. So this is on real user monitoring. So I'm taking the logs task. I'm not sure that anybody is front end, but I'm taking the long task context duration, right? It's a string, obviously, within logs. I'm changing it to a numeric, forcing it to be a numeric. So first of all, I'll take the logs, again, context of 6 hours. I will filter that the long task duration is above 0. And now I want to group by case less than, right? So I don't care about the real value. I want to aggregate it in buckets that I'm choosing. So if it's below 100, it's good, right? And that would be the value showing. If it's below 200, we mean 101 to 200, it's medium. 200 and 302 is bad. And everything above 300 is need investigation. That would be the output, right? Good number, medium number, investigate number, bad number. And for your question, if I'll copy that query into either of the Visual Explorer or to our custom dashboard, you can visualize it. Same query, output that is a pie in this case, okay? Cool. Next example. Next example. So this is a long example. And note, again, that I've left this as part commented out for an additional aggregation. And I will talk about the power of piped language, right? So here, for example, I'm taking my logs, right? I want to have a fast name. These are logs that are coming from lambdas, okay? So I want to force it to have a fast name. Now I'll group by the fast name as lambda, another rename, the execution as execution ID, and now I'm aggregating. So I want to know how many logs this execution wrote. I want to know the minimum start time. I want to know the maximum start time. And now that I know these minimum and maximum on these logs, I can create the duration, right? By calculating end minus start. And I'm converting the duration into numeric value. So if I'll scroll to the left, I will see the duration here, right? So this is the output. Execution ID, we had a lambda name at the beginning. The number of logs, where it was started, which means it's not really started, it's the first log event of that execution within the time frame, when it was ended, and what is the duration between them. Now, if I want to do a second level aggregation, I can enable this additional filtering. So I will do second level aggregation. And I have the data, and I can use that data in order to do a second level aggregation. So now I want to know it on a lambda. I don't care about the execution ID anymore, right? So I want to group by just by the lambda, and I want to have the sum of duration as sum execution, the average duration as average execution, and even the percentile as a percentile, right? And now when I'm doing a round interval, instead of getting a number, I'm getting a human readable number. So I know that this lambda ran 3 hours, 9 minutes, 26 seconds, and 4,300 milliseconds. This average execution is 21 seconds, roughly. And the percent of 95 is 2 minutes, almost 3 minutes, right? So I have value on lambda. And I can enable it. And again, I can save the query as enable or disable, and then I can do second level aggregation on the same query. Another example. Cool. So this is calculation of budgeting. Cool. So we know that we have in lambdas the report invocation, right? So I want to source logs. I want to filter only the report events, right? Lambda report events. Go by the fast name, which is lambda, right? And now I want to aggregate. Count as invocation. This will give me the amount of invocation within the time frame. Sum of the build duration as total build milliseconds. And the average as average build milliseconds. Now I know that, for example, my budget is 0 something dollars for each invocation. So I'm creating a new field, total cost. And again, structuring my data as round total build duration times this and 5 digits, and adding the dollar sign. So my output will be the name of the lambda, the number of invocation, the total build milliseconds, the average build milliseconds, and my total cost, right? So again, I can create different views based on my data. I didn't have the total build, I didn't have the average build, and obviously I didn't have the total cost, right? Looking at logs and giving me insight on my logs. For my sixth example, which is a cool example. So this is a very interesting use case. So we have a store, right? And we do transaction in different currencies. And obviously we have failed events as well, okay? So I want to know what is the number of failed events, what is the average deal size, and how much money did I lose due to these failed events. But the problem is that I'm having 4 different currencies. So how do I know what is my average deal size with 4 different currencies? So we wanted to have both failed and valid events. So I'm filtering either invalid credit card info or transaction amount is larger than 0. Okay? So I have my good and bad events as my filtering events. Now I want to create transaction US dollars. So in order to have my average transaction size, I have to unified currency. Okay? So I have a case, equals. And I'm looking at the currency. If it's US dollars, I'm multiplying by 1, obviously, right? If it's euro, I'm multiplying by 0.4. And again, it can be used, as Moran mentioned, from external sources. So I can use an Excel sheet that has the actual currency, which updates every day, and I can reach it from actual currencies. Euro is 0.1, Japanese yen is 0.066, and Canadian dollar is 0.69, right? So up at this point, I have a new field, which is called transaction USD, which is a unified deal size in US dollars, right? Now I can group by the timestamp on an hourly bucket as time, and I want to aggregate. So let's look at what I'm aggregating at. So if it's an error, count. If it's not an error, count it as successful transactions. I want to know the amount of transactions I have, right? If it's an error, then count it as an error transaction. So up to this point, I have the number of successful transactions and the number of failed transactions. Now I want to have my total. So I'm rounding up the sum of transactions as total revenue, okay? And I'm rounding, and I'm filtering in with a dollar sign. And I'm rounding this field as the average revenue. Now I want to know what is the lost. So I'll create a lost revenue, so a typo, from the average revenue multiplied by the error transactions and order by time buckets. So what I will get in this time is on an hourly bucket, the number of successful transactions, the number of failed transactions, the total revenue, the average revenue, and at the end here, my lost income. Okay? So I know in this hour I've lost, how much is it? $200,000, right? Obviously, it was not in the logs, any of it, right? So it's a huge calculation that will give me insight on my business, not just searching logs, okay? Another example based on the same context is I want to know, out of my successful deals, how much I'm getting through different credit card companies. Okay? So I have my credit cards provider, and I want to have the number of transactions, the total revenue, and average revenue. And again, know that I have 4 different currencies. So again, I'm taking this value, and I'm creating a unified deal size based on the original data set. Okay? So if it's a US dollar, it's multiplied by 1. If it's a euro, I'm multiplying by 0.4, and so on. Grouping it on a time range. This time I'm adding the credit card into the aggregation. So not for every hour I'll have 2 aggregations because I'm getting data from Visa and MasterCard. I know how many deals I'm having with Visa, how many deals I'm having with MasterCard, and my total income and average. So not that the average revenue is the same for both credit cards, but due to the fact that Visa has more deals, I know where my money is coming from. Again, business analytics on raw data from your logs. Last example, and it's a really complex one, so we'll go over it slowly, okay? Let's try to open it all the way. Okay, cool.
Looks like we will need to hire a
No. It's again, as Moran mentioned, you can start slowly and ramp up, but just as a context of what you can do from your DataPrime queries. So in this case, I'm looking at spans, okay? I wanted to know where do my API errors coming from. Yes?
For all these things, you have some parameter store because the reflection by the currencies, for example, it's something that can be changed every day.
Right.
Currency changing every day, and I want to have some parameter store to declare the value there.
Right. So the question was, can we use parameter stores in order to have variables within the DataPrime query? So as Moran mentioned, and Arel will show in the example, you can use enrichment. So enrichment has the ability of uploading a CSV, and it can be done on API on a daily, hourly method, right? And then you can use source enrichments in order to add contextual data from data loaded into the platform. So yes, you can. So again, I used static values, but I think Arel will show the use of dynamic values. Cool? And the good thing about using dynamic values is when you're doing enrichment on the fly, you don't care what was the rate on the time of ingestion. You care what is the current rate. So you can change data, again, by updating the contextual data. Yes?
In case I do care about the value that I used to have, for example, if I want to use DataPrime in housing, can I do it? Like with
So DataPrime,
enrichment and DataPrime on my logs. So in that way, I can actually see what was the value back in the day.
so again, the question was, can I use enrichment and DataPrime in order to manipulate data? So yes, you can use parsing in order to ingest to change the data upon ingestion. You can use static enrichment to enrich the data upon ingestion. However, you can use DataPrime to change the enriched data on the fly. So if you want to have the original data, you can show the original data. If you want to change it, you can use DataPrime to change it. So you can play around with it in any way that you want. Okay.
Yeah, and one more point on this, like the same semantics of DataPrime, we're working on providing the same syntax as a parsing rule, so we'll be able to just copy-paste it you will be able to just copy-paste the query into a parsing rule, and the same logic will apply. And it will also allow you to enrich stuff and then do other additional processing after the enrichment during parsing, which is something that is limited in the current implementation. So this is part of what we're doing.
Cool. So let's get back to the example, right? The complex one. So I'm sourcing spans, and I want to do on the last 2 hour spans, right? 24 hours, I'm ignoring that again, taking spans on the last 2 hours. I'm filtering tags with the HP status code over 399, right? So 400 and higher. So all the 4XX and 5XX, right? I want to choose. So now I'm choosing. I'm not grouping by. I'm choosing, right? I want to narrow down my data. I don't care about all the data. I want to narrow down on the needed data. So I want to choose the timestamp as the error time, right? That's the error time. That's the time that the error occurred. I want to have the service name as the error service, and the operation name as the failed action, right? So now I know what failed, which action, which service, and when, okay? And I have the trace ID, obviously, and the status code. I want to know, is it the 400, the 500, and so on. Now I'm doing another join. Now this time I'm looking at the 3 hours. I'm taking into consideration that the trace can start an hour before the actual error, right? So I'm adding context. I'm broadening my search time, right? So I'm taking the last 3 hours. I'm choosing the timestamp as the start time, the trace ID as trace, the operation as action, and the service as service, starting service, using trace, so I'm correlating on the same trace ID, okay? Into root. That's the root flow, okay? That's the starting point. However, and then I'm creating a time to fail from error time as timestamp minus root. So I failed here. This is where I started. This is the time it took to fail, okay? Now, since there are orphans that don't have, that can have, which are not, can appear here. So I want to have the filter larger than 0, right? So I want to see only root spans that started before my span, okay? So all the negatives I'm ignoring, I'm deleting them here, okay? Now I want to do another aggregation. I'm looking for logs. If I want to investigate an API error, I want to have a trace that has logs. Otherwise, I won't be able to investigate, obviously. So I'll do another source, logs. 2 hours is enough because I'm looking at the logs of the failed event, right? So in this case, 2 hours will be, again, enough. I want to have the trace ID, which is not equal null, right? So only logs, which is trace ID. Group by the trace ID as trace. Count as logs. Count as high-severity logs into trace. Using trace, or into logs. So now I'll have 3 different data sources within the same query. I'll have the original error, I have the initiator span, and I have the logs, okay? Now I can start to do the buildup. So I want to have only high-severity logs. If I had an error, I want to make sure that I have an error log or a warning or a critical in order to help me identify and investigate. Now that I had all the filters, now I can choose and structure my data, right? So what do I need? I need a trace ID. If I want to investigate, I need a trace ID, right? For the APM. I want to have the root start time as started, the time to failed as failed after, the status as the error code, the starting service, the starting action, the error service, the failed action, the logs, and the high severity logs. Once I'll have that, if I'll narrow this down, then I have noted that in this case I didn't do a group by. So I'm not looking at the data as tables. I'm looking at it as JSON, which I've structured, right? So I created a log event based on the data that has value to me as a developer, right? And in that, let me expand one of them. I can see the trace ID in question, right? The starting service, the starting action, the started at, how many high severity logs do I have, failed after what time, what was the failing action, what was the error service, the error code, and how many logs. Now I can look at that data and see which trace will bring me value in order to investigate it. And I can jump to the APM screen, look at the specific trace, look at the flow, look at the breakdown, look at the correlation between APM and logs, and bring me value. So again, this will help me analyze my data source, bringing me the value quickly, right? Now I know where to look for. So out of looking at 1 million traces and starting to see which trace bring me value, I can jump directly. And again, I can order it by the amount of error codes. So only the trace with the most error events. And I will investigate it because it has more value, obviously. If the beginning service and ending service, and I can filter. I don't want to see that the starting service is load generator. I'm not interested. Or I want to see only failed actions which are not HTTP post but other action, right? So I can filter it in any method that I want in order to gain value. This is DataPrime in a nutshell, right? Just to show you the abilities, part of the abilities that resides within that language in order to bring you value. Any questions? Yes, wait.
Hi, I have two questions. First off, many times we want to query over something that we already did a query. Do you have a possibility like to query from a specific view or, for example, these kind of queries? I don't want to write 20 line of query again. It could be nice if you have something like that.
Okay. So again, in this case, you can save queries.
I can save query and then query over a query in a new screen.
You can duplicate the query and start from that. You can copy and paste it. You can add additional. You can open a predefined view within a query and then continue to add additional steps to that query without saving it. Pipeline. Yes, exactly. You can add additional pipelines to the existing query. Without changing the view, it will keep the original one as is, but you can manipulate with the data.
Yeah, and add to that as well, like named queries. No need. No need, Tal. Named queries and saved views are going to be automatically named queries, so you will be able to actually reuse them as a source.
As a source for the different query.
Exactly.
Yeah, perfect.
And also, I'll talk about it in my presentation as well, but we also have the feature of background queries, which is currently being exposed. The results of each background query will be exposed also as a data set, so we'll be able to do some big analysis, like a long-term trend analysis, and then reuse it in the Explore screen in order to do further processing.
That's great. And the second one is how the real-time engine or how you optimize the queries if you do any kind of optimization, because we don't control the indexes like in a SQL database, but this is very like SQL and the indexes are...
I'll touch it in my presentation.
Cool. Any other questions?
So just to make it clear, what is the runtime for this kind of query, for example, can be?
With the runtime, I can show you. I'll do a runtime. Again, these 3 queries, right?
24 hours.
Done. This is running from the archive, 3 queries, done.
Thanks.
Yeah, don't forget that you can actually, after creating this query, which is obviously a very elaborate one, and that you're gradually iterating over and creating, you can save it as a widget query in a dashboard or as a saved view, and you don't need to go through the entire process every time. Or other users in your team can actually reuse the result without actually dealing with the writing every time from scratch, of course.
Cool. So thank you, everyone.
תבדקו לגבי ההפסקה. My presentation will start in a minute, but I think that we need to take 5 before continuing. I have a long presentation. Let's be back on 11:30.
Hello. Testing, testing. אפשר לשבת כולם? Let's sit everybody. טוב, נסיים לאכול ובואו נשב כולם. יאללה, חבר'ה. יאללה, כולם לשבת. המיקרופון הוא לא משמעותי. אפשר לשבת ונמשיך להרצאה הבאה. אנחנו מתחילים. הייתי עושה את זה, את יודעת, אם זה הרב, הייתי עושה את זה. טוב, אנחנו מתחילים את ההרצאה הבאה, אז אפשר לשבת. בסדר? לקחת איזה מנה טובה ולשבת, מה אתה אומר?
מה שקורה,
אפשר לשבת, כולם לקחת סנדוויץ' לדרך. לדרך לכיסא. קריאה אחרונה לישיבה להרצאה הבאה. כמה מרגש. Let's sit down everybody so we can start to the next presentation. Everyone take your last something to drink, something to eat, and let's sit down. All right, everybody? I can't even hear myself. עכשיו זה הזמן לקרח. הנה, אפשר לשבת כולם. בסדר, All right, everybody, last call. We can sit and we can start with our next presentation. Thank you.
Okay, so hi everyone. First of all, I'm excited to be here because it's amazing from my perspective to see DataPrime on the screen. But even more than that, I'm not really used to talking in front of people, especially not being broadcast live. So forgive me if my English will be a little cranky at times. I would like to talk about, maybe there are two parts to this presentation. The first one is how DataPrime connects to the Coralogic vision, and I'll talk about it in a second. And the second one is related to the DataPrime language itself. We'll touch a lot of subjects. Quick word on who am I. Ariel Ben Attia. I started actually at age 6 with a ZX Spectrum, like with 48K RAM. The amount of data that we're dealing with today is like amazingly bigger, so it's amazing to think about that. I was actually working for software companies since I was 14, a kid with a lot of ego probably, because 10 years ago I actually went to a legal office and one of the applications I wrote, like when I was 14, was actually in use there. And the lawyer there didn't believe me, so I actually had an Easter egg inside the code that proves, as a 14-year-old kid, that proves that I'm actually the writer of this code. So it's nice. A long time ago, very, very long time ago. So I'm the chief architect at Coralogics for the last 4.5 years. I won't be able to see you, I'm sorry. It's like I'm too old. The glasses, I need to see the screen. So if I'm talking to the wrong guy or woman, so please forgive me. So I'm the chief architect of Coralogics for the last 4.5 years, and Coralogics kind of resonates a lot with, like the Coralogics company and product resonates a lot with with who I am, I think, maybe. My goal or my meta goal is to enable Coralogics to actually grow exponentially with linear effort, both from a product, engineering, organization, and business perspective. I'm touching the architecture on all aspects of the company. And hopefully, what we're building here is actually a product that will help you as customers to achieve similar goals on your side. I think that when I talk about Coralogics vision, then maybe this will connect. So what are we going to talk about today? First of all, the DataPrime engine itself and its key features. Secondly, how DataPrime connects to the Coralogics vision. There are two aspects of the Coralogics vision which are extremely important to talk about, like the observability evolution challenge and maturity levels of companies, and what we are calling organizational intelligence. I'm going to talk about the design approach and the rationale behind DataPrime and why did we decide to actually create our own engine. I'll dive a bit into the concepts of the DataPrime language itself, and talk about one of the questions that rises. Even someone today mentioned it, like comparing DataPrime with traditional SQL. We'll go over some examples, a little bit about implementation highlights, and some work in progress that we're doing. So the DataPrime engine is actually an analytics engine for nested heterogeneous data. So nested is obviously the familiar JSON data. We didn't want to go with something which is unfamiliar. And heterogeneous means that each event can have a different structure, and I'll touch about this design decision a bit later. It actually bridges the gap, like the engine itself bridges the gap between heterogeneous data and analytics at scale. And when I'm talking about scale, I'm not talking only about the amount of data. I'm talking about the time range between minutes, like for interactive, and years for trending. And obviously, from a cost perspective, scaling from a cost and efficiency perspective, like the cost and the price to you as customers. And from an organizational perspective, how to fit to small organizations of 5 people up to large enterprises of 1,000 people and so. And one of the prime concept, I think regarding the DataPrime engine is that, and Coralogics in general, is that we are aiming to provide commoditized analytics. Like there is no need for any engineering middleman or analyst in order to actually perform analytics like end to end. And I'll touch this subject during the session today. A bit about some of the key features for DataPrime engine. Ingestion and schema management. We're supporting both streaming and batch ingestion. Nested data is native to the system, including complex data structures, which are usually not being handled in other systems very well, like arrays and arrays of objects. I'll show an example of it at some point in this presentation. Large-scale dynamic schema handling with real-time automatic detection and updates. No need for predefined schemas, built-in conflict resolution, as we'll see, and advanced discovery autocompletion and validation mechanisms. This is one aspect of the commoditization of analytics that I'm referring to. Data storage and routing, we have a multi-tier architecture. Frequent search data is being stored on our own internal systems. And we have obviously native support for customer object store, allowing the customer complete control over the data. The storage and the access layer are both optimized for efficient storage and handling of thousands of fields. And we have also in the engine seamless forwarding capabilities to external systems such as Kafka, because one of the important things I think about analytics is that you never want it to be a sink. You want to do something with it and then continue processing it or push it to some other systems. Advanced querying, as you saw in the last in the previous 2 sessions, complex transformation, obviously more powerful than Lucene, but much more intuitive than SQL. I'll touch it later. Strong extraction capabilities. The idea is to be able to convert unknown unknowns to actionable insights, and that requires a lot of abilities to structure and restructure data in a way that would make sense and would provide the necessary insight. Native support for enrichments, joins, and unions, mixing and matching data from multiple sources. We are already a long time ago, like 2 years after dealing only with logs and spans. There are the system itself and the engine itself natively supports multiple data sets. I'll talk about it a bit around the features that we're building around it in the work in progress part. And very, very importantly, to any system, I think, today, with the amount of data that we're dealing with, etc., which has grown over the years, is that free text search is built into the engine, obviously with similar semantics to Lucene, not only because of backward compatibility requirements, but also because Lucene, for the most part, is like at least the simple cases are readable and familiar and useful. Two use cases, I mentioned it a little bit earlier, interactive queries for real-time analysis and dashboarding and ad hoc exploration. This is what you mostly saw in the previous examples. And background queries for long-term analytics and trending. You can run much larger queries which take much more time. The query results are actually being written to a data set in a way that would probably in a few weeks will have the beta of reading it directly as a source, like the actual results being read as a source and used as a source for further ad hoc exploration. And something else, like with regard to the DataPrime engine in general, like we are the part related to the expressions and the power of the expressive power that DataPrime provides, and the concepts behind it are actually used throughout the product for many other use cases. We call it the DPXL, the DataPrime expression language. It's already being used in the product in scope definitions, in filtering Kafka out. You can configure the Kafka out to say, to provide an actual DataPrime expression of what you want to push out. You don't want to push the entire data in most of the cases, yeah? And this is gradually covering the entire product line, like in other cases, in other places as well. So I want to talk about how DataPrime connects to the Coralogic's vision, and for that we need to touch the actual vision, obviously. The premise or the statement that I want to touch here and to make sure that we understand is that Coralogic's vision actually requires analytics as a first-class citizen. There are two major aspects related to the Coralogic's vision that are very, very important, and I'll want to dive into them a little bit in order to understand a bit more. So one of them is the observability evolution of organizations, and the second is what we call organizational intelligence. The connection to DataPrime, and I'll show it more deeply in a second, is that DataPrime provides strong analytics and also makes it a commodity. Like I said earlier, there's no need for the engineering middlemen like data engineers or specialized analysts or bureaucracy in order to actually perform analytics. This is something we would like to eliminate from the equation. So the observability evolution. Systems obviously today are complex, dynamic, ever evolving. The speed of evolution has risen. And observability is obviously essential. No one says I don't need observability. But the question is whether monitoring your systems is enough. And we want to answer several key questions related to that. How does observability evolve as the teams mature in terms of observability? What kind of observability actually enables us to utilize it in order to do true system evolution? And why our analytics capabilities are a necessity and not a luxury? We'll talk about three phases maybe of observability: reactive observability, proactive observability, and creative observability. And I want to compare between them. I don't want to go into all the details. I don't think it will be needed, but just mostly touch the mindset. Like in reactive observability, the team mindset is usually like old school monitoring. It's an insurance policy that you only touch the observability system if you have a problem. If someone reported a problem, you go to the observability system. It's a very costly insurance policy, and it's a very, I think, limited form of being able to utilize observability to the maximum. With proactive observability, it becomes a tool for understanding system behavior, so you're not only dealing with it only when there is a problem, but you're more proactive about it. And I think the highest level of maturity is when teams move gradually to creative observability, which is saying I can actually design the input to the data the input to the system, to the observability system, in a way that would allow you to allow me to actually understand the things I care about as a team member or as an admin or whatever. And I think that this gradual path that companies are taking is something that allows to unlock extreme value from observability system. Think about the reactive observability phase. The observability system value is actually only retroactive. The value is realized only after the incidents occur. With proactive, it becomes a little bit better, but when you're moving to creative observability, the ability to get continuous and exponential value that actually drives the company growth becomes very, very prominent and becomes a reality, closing some kind of of a feedback loop of improvement that I saw a lot of cases where it actually takes the company forward in ways that were not possible before. One more interesting aspect of relationship between the maturity level is that reactive observability is usually search-based because the driver for actually accessing the system is a user that has a bug or a reporter that says I had a problem. So you're usually searching for the session ID or the username even or the email, etc. Or for infrastructure problems like Kafka error or whatever. But when you're moving to proactive or creative observability, the analytics use cases become more and more prominent and provide a lot of more value than just regular search. Obviously, search, like I said, it's a native part of everything. Even in Shiny's Yal, the second presentation, there was, I'm not sure if anyone noticed, but there is a count if of an expression that actually uses free search, free text search. Yeah? And this combination of analytics and free text search is very powerful. And DataPrime's key features, like to summarize this, the DataPrime's key features enable and help teams to actually, wherever you are in this journey, I think, then I think that DataPrime and Coralogics in general are great enablers in order to actually move teams' mindset in order to actually naturally move to the next level. It becomes more natural over time. So I'm not sure if all of you or some of you have seen the Coralogics observability maturity model. There are a lot of additional details there. I don't want to go into them, but when we're mapping the reactive observability is actually level 1, and proactive observability is levels 2 and 3, and reaching level 4 with business insights is creative observability, and that's the relationship of this part to the Coralogics vision. The second part of Coralogics vision is what we are calling organizational intelligence. An organization is effectively a single organism, and an organism needs to be treated as a whole and not have decision silos. Effectively, it comes down to decision silos, to the fact that if two parts of an organization or an organism as well would take the decisions separately, the decisions would eventually be much, much worse and might even kill the organism at some point. By the way, I just discovered it while writing the presentation that organization and organism are from the same root. It's a structured whole, and that's not surprising, actually. Coralogics we believe that observability must become organizational and not internal to the R&D. Like, as Ariel mentioned in the first presentation, the observability data is by far the largest amount of data that's being generated by an organization, and it's a complete waste of time and resources to actually not utilize it both for R&D purposes and obviously outside of it. And once we're talking about organizational data, then the need to actually combine multiple sources in order to increase the value becomes more and more important, because it adds more context. And then each piece of data, like we saw in the previous sessions, each data becomes much more valuable on its own because it gets additional context. So to summarize this, like, we are aiming to provide natural means to integrate between business and observability data in both directions, both taking observability tooling and capabilities and mindset into the organization level and the business level, and also take data and metadata from the organization into the observability in order to augment the value both ways. And the end goal is to utilize observability for making business decisions across the entire organization without having decision silos. So organizational intelligence is effectively engineering and production intelligence coupled with augmented by business data. We have a simple example. I can talk about it more deeply like later if anyone is interested, but our own product catalog is actually an internal project that aims to connect between each of the products that we are actually providing to customers to the cost of each product in terms of services and infrastructure, and to the cost of human resources and dev maintenance effort through Jira. Yeah? And the idea is to connect have a single line, a single thread that connects all of these layers as one into one system, like it's our own account, C4C, Coralogics for Coralogics. That's the name of us as a customer in Coralogics. And everything goes there in order to provide the necessary analytics. So analytics-driven observability, like I said, proactive and creative observability obviously demand advanced analytics, and organizational intelligence depends on integrating business and system data and obviously requires analytics as well. Bottom line, observability is not just about knowing what happened, it's also about understanding and shaping what will happen next, and it's the foundation of evolving both the system, the technical one, and the business. We want to enable customers to actually evolve their organizations by making better business decisions as a whole and not with decision silos like I mentioned. Okay, so why did we decide to actually create our own engine? This is also a question that is an important one to answer because there are a lot of analytics engines and they're evolving obviously rapidly throughout the last years. So we decided that we need to natively, in order to maybe, like I mentioned earlier, like dynamic schema management and in large scale is actually a native part of making analytics a commodity. And one of the things that we wanted to bring into the system in terms of value is to natively support large-scale dynamic schema management, which has several limitations in existing analytics solutions. This is obviously advancing because everyone understands that this reduces friction and allows a lot of valuable things. I'll talk about it more specifically in one of the next slides. Seamless product focus experience across our entire product line. We don't want to depend technically on limitations of a specific technology. Arrays of objects could be an example. Reducing cost and prices by being able to optimize the storage and the resource efficiency on our side that allows us to bring cheaper products while providing value for the customer. There's a lot of work that's being done, obviously, and being done on being able to efficiently write and query the object store layer, which is a cheap storage for interactive purposes. And we are mix and matching a lot of best-of-breed stuff, both from a product perspective and like providing different features, but also from a tech perspective behind the scenes without actually exposing you as the customers to the details or to the limitations of this. Dynamic schema benefits, like I said, it's one of the pillars for making analytics a commodity, and it's an important point to understand why is dynamic schema really a thing, okay? Best advantage maybe is minimal coordination and configuration overhead. Strict schemas require a lot of communication. Add this field, please add this field to the data set. Oh, I want this one as well. Now I'm folding the data to another data set, so I need to propagate the change. You need to talk to an admin. There is a lot of bureaucracy there, or even worse, like requiring a data engineer. This is something we wanted to eliminate from the equation, sorry. And because our system natively supports streaming ingestion, this even becomes more important because we never want the customer to lose data, definitely not because of bureaucracy. Yeah? It's like we started streaming the data and the admin didn't add the relevant field, so what do you do with this data? fail the entire ingestion, you remove this field and then the data is partial, etc. We wanted to get rid of the need to actually deal with these questions. And like I said, data structure becomes a commodity. The user can actually, and this is something that's related to the maturity model, I think, that I've mentioned earlier about teams moving forward in their mindset with regard to observability. A lot of the, like I think that an important point where people are actually moving to the next level is, especially from reactive to proactive, is being able to realize, and by the way, also from proactive to creative even more, yeah, is that people are able to actually realize that they can actually shape the data as the user creating the data in order to understand what they care about, like I mentioned. And this power of playing both sides effectively allows to actually instantly get analytical insights. Our engineers are actually doing it all the time. What Eyal showed earlier about our DataPrime query analytics, these are just simple logs that the DataPrime engine actually emits very, very simply. They are being shipped automatically into C4C, into our own Coralogics account. And like 10 minutes afterwards, after they started sending the data, they actually created a dashboard and they have analytic information about what happens in the system. And that was amazing to see. No bureaucracy, no coordination was needed whatsoever. And since we are talking about logs, events or logs, like a log, it's a very old word for just an event, yeah? Like since we are talking about events and not metrics, the analytical value is extremely high. I'll give an example. Like one of the fields in the DataPrime analytics is not just the query text. It's actually a blueprint that we are generating from the AST of the query in order to do a group by on query patterns in a way that would allow us to understand the relationship between specific query querying patterns and the duration that they're taking. And that allowed us to optimize a lot of common query patterns, or even discover bugs where something you expect a specific common pattern, query pattern to actually be very quick, and it's slow, and you say, oh, I have a bug here, and one day afterwards, this bug is gone. Yeah? And this is something that in a metric-based monitoring you would never be able to achieve, because you would need to choose very carefully the labels. There is definitely no room in a metric for half a page of a query, like Shiny says, shown the last crazy query. It's very crazy. It's like most queries are not that crazy. But still, like 200 character query is not something that's realistic to send over a metric label. And each of the DataPrime query analytics actually spits out 15K of information then, in order to provide or help us with all the analytical insights that we want to gain. And another argument regarding dynamic schema is that it's needed today more in the past. Like in the past, there was a slower rate of changes in the past, and today the organizations themselves are more decoupled relative to 10 or 15 years ago, where there was a DBA and you would ask them to do something, and there was one database. Like everything is much more distributed and decoupled, and there's a lot more data. So obviously, dynamic schema is more important today than it used to be. I want to talk about the challenges that it brings. Like dynamic schema is nice. Let's have dynamic schema as a nice statement, but it brought up a lot of very important challenges that we have solved. You can see on the left here, like I'll talk about them. First, like smart schema discovery capabilities, like field and value auto-completions. You can actually see the top image on the right, like auto-completion capabilities. You already saw it when Eyal was actually typing, but they are very smart auto-completion capabilities, very similar to an IDE. And there's also value auto-completions. You can see in the second example on the right, like API inversion equals, and then you get a list of the actual values, so you don't need to type them, and you get the data surfaced to you instead of searching for something. It's instead of a search, effectively, yeah? And additional usability features such as validation to warn the users if they're doing something crazy that doesn't make sense. We have full query validations based on the schema and quick fixes, etc. Schema management capabilities like the schema exploration and reserved field features that are soon are going to be in alpha. And straightforward conflict resolution. What happens when two sources or maybe even the same source change from a number to a string because they decided to? You need to be able to allow the user to deal with that. And if you look a little bit closely, I hope it's not too small, but if you look at the first key suggestion, like the field suggestion on the top right, maybe I have a, no, doesn't matter. Like the field suggestion on the top right, company ID, then you see that it's a number or a string, yeah? And that's an important point, yeah. That's an important point. The DataPrime schema tracking contains, it's a native part of the entire engine. It supports union types, like there is a type number or string, like you see in company ID, because the system has actually observed it both as a number at some point and as a string in the relevant time range, by the way. It's, the entire schema is time range driven. So for yesterday, it might be a string, and today someone started to send numbers as well, or maybe instead. And if you're doing a 2-day query, you will get number or string, but if you do a 1-day query, you will see only a number, yeah? And that allows you, we have features inside the language itself that allow you to resolve these conflicts in a way that's really native. There's no mapping exceptions or issues related to saying this can be either that or that. It could be both, okay? And automatic detection of breaking changes. We have an upcoming feature which is called Auto Validate Dashboard. It actually sends the dashboard. It will send the dashboard owner or creator. It will actually test periodically whether all the queries are not failing and return data, and would actually send a notification to the owner of the dashboard if something breaks. Okay, so we talked about the need for analytics and why we built our own engine and dynamic schema. Now I want to dive into the actual language itself. So the language itself, like we've seen in the previous sessions, is an actual interface to the engine. Most of the points that we've been discussing in this presentation are obviously reflected in this interface with the ability to deal with the known unknowns. The language has been designed to balance between power and simplicity. Maybe everyone aims for that, but we also. A small, highly composable set of idioms or commands enabling a shallow learning curves. Most of the queries are could be understandable even by a person that doesn't really have any clue specifically about DataPrime. They obviously need to understand the data and the concept of data analysis. But apart from that, it's mostly readable. Extensive support for full-blown expressions everywhere. It's not like the language seems like a language. It's a real language, and which means composability. And composability means that you can mix and match things without saying, oh, in this case I can do that, in this case I can't, etc. In most of the cases, things just work. And there is inherent type inference, which is kind of the usability feature or another usability feature related to the dynamic schema handling. Instead of actually forcing the user to actually deal with the fact that there are types, we are mostly eliminating it from the user's perspective when they're writing queries and dealing with that internally as part of the implementation. And only in cases where there is a need for conflict management, etc., for conflict resolution, we expose this as warnings to the client, and the user can actually choose what to do. Okay? DataPrime was written with a so-called flat mindset. People think flat, even if the data is nested. So operations are flat, like users are very, very used to doing stuff linearly, like take A, then perform B, then perform C, etc. Queries are much more readable and easy to debug in that way. Fields are also flattened, obviously, like x.y.z for nested data. But the important part is that the engine preserves the nested structure at any point in time, unless the user actually decides to get rid of it. Expressions are also flat by nature, but because expressions, there are too many people who are used to nested expressions, then we support both. In the example on the right side, you can see that 2 lowercase hostname and then split part, and I could add another period and then do something and then do something as a flat expression. But the native nested expression, like the mathematical nested expression syntax, is also available in DataPrime natively. There's no difference between them. It's just methods versus global functions. But from a user perspective, it can make queries much more readable to other users and maybe to your future self as well when you're coming to your query like a week after. And complex data manipulations, like I said, joins and unions are also flattened as well. Makes things easier to read. Basically, there is, in most of the cases, even if you have like 10 joins, you would still be on a nesting level of 1. Yeah, like a maximum nesting level of 1 and not like 5 or 6. So comparing DataPrime with traditional SQL, I have an open source which is SQL related. I love SQL. It's really like, it's an amazing language and amazing concept. And simple queries are obviously great, a little bit verbose sometimes, but fully composable. But it has several advantages as a human interface. First of all, it's related to what we just mentioned about the flat mindset. Flow is expressed in a nested manner. F and then G are actually expressed in a mathematical way, like G over F. Nested data is less native, even though a lot of SQL engines obviously go towards nested data, full-blown nested data support. In most of the cases, it doesn't work on a large scale, like most SQL systems will not be nice to you if you have like 3,000 sparse fields. And writing complex SQL, an efficient one, complex is maybe easier, but complex and efficient SQL queries takes a long time even for experts. We have our own example is a very simple one. I want to share it with you. Like we created, like when we've written the DataPrime POC, we actually created, in order to test the initial file format that we were designing, we actually generated, dynamically generated SQL queries to Athena just to see, to validate if the initial file format is okay for us. And a 4-line DataPrime query actually required 3 pages of SQL queries with 6 nesting levels in order to be efficient. Yeah? And there are several ways to do that, etc. But I want to show that even though DataPrime uses a lot of SQL concepts, and it makes them much more accessible and reusable. So let's see a couple of examples. Simple query is very nice, you know, in the SQL as well. It's not, there's no big difference. A little bit verbose because the group columns is actually duplicated in SQL versus DataPrime, and there might be a little bit more error prone in SQL, but that's not a big deal. But if you like to do and take another second group by, like Eyal has shown, as a second group by over an existing group by, then that becomes like totally different. Like in the SQL query, you need to wrap the additional group by on top of the original one. But in DataPrime, the only thing that you will need to do is to actually add the pipe group by and think what happens to SQL queries. How does it blow up when you have 5 or 6 stages of processing that maybe the first processing stages you're not even the one who wrote it. Yeah. So in DataPrime, you will mostly not care about what is already written. You will just add another pipe and continue. Okay. Okay. So I want to touch a couple of examples. How will we time? 20 minutes. So I want to touch a couple of examples. So on the left side, maybe now it will be nice if I. Does this show in the video like the pointer? Yeah. So we are looking at a string message. Yeah, that contains actually effectively contains some amount and credit card information. It's not really real data. Yeah, of course, it's an online boutique, so it's dumb, the credit card. but like a dummy credit card. But effectively, this is a JSON string within the log, yeah? And I want to take the, just a minute. I want to, oh, just a minute, I'm sorry. I jumped one more example. So, example 1, okay? That's example 2. So I want to convert this string-based list of product and quantity pairs, they are part of a string here in this message, into analytical data, and I want to aggregate it per state. You see the MD here is Maryland probably, yeah? And this is the list of the product and quantities for this tracking ID. And I want to aggregate over it. So this is the query, but I want to show you a little bit of the actual flow before, and not just the end result. Is the screen visible in the recording? Yeah? Okay. So, so let's take a look here. We see like this is the actual end result, but I want to show a little bit about the process, okay, of writing a query. So I will delete everything apart from the filter, the initial filter. And we can see that, we can see, just a minute, we can see the message here that I was just referring to, okay? And now I will, it's too small the resolution, just a second. That would be better. And now I'm going to extract the field message into a new field I'm calling extracted, yeah, just for the sake of the example, with the regex. And this, when I run it, then this will actually show me the data, the original data, but with an additional top-level key called extracted, yeah, and with the 3 parts like the item string, the state, and the tracking ID. And if you remember, the item string, just a minute, just for the sake of the example, I'll do a choose extracted, so we'll be able to see it in the in the grid here. You see that we kept only extracted just for the sake of showing it to you. So we have 4 fields here, okay? And now I'm going to continue, yeah, to the next part. And I want to actually extract the product ID and quantity pairs as a multi-regex. This actually takes the item string, which, as we saw, is just a string containing pairs of product ID and quantity, and it extracts it into an items array. We'll see it in a second. That in addition to what everything else that we extracted, let me choose extracted again, just to show the extracted information easily. Yeah, it's like we see that extracted contains everything that was there before, but it also contains an items array which has the actual items in the list as separate ones. And now I'm going to do something interesting. Like if we do a count here, then we see that we have around 8K of data. But what I would like to do is to actually do something called explode. I want to take the array of items and I want to convert them into separate documents because I want to do more analytics on the product and the quantity. I don't want it to be part of an array in some document. So if I do explode, I'll do a count first, so you will be able to see that suddenly there are more documents here, like it rose from 8K to around 12K. Let's take a look at the extracted data. Oh, by the way, I have an error here because I only chose extracted, but effectively I asked item to be at the top level. Like I said, the nested structure is kept unless you explicitly ask for it. So I could either do an into extracted.item, but I chose to do it at top level, so I'm choosing item as well, so we'll be able to see the actual content of it. And you see that now each document, first of all, contains the original extracted information, and secondly, contains the item string. Something I skipped here, which is the original preserve, means that the original information is being duplicated into each of the exploded documents. If I would not care about the, you see, just a minute, this is an interesting point. If I would not care about the original content, I would do an original discard, but then the actual schema tracking system tells me extracted does not exist anymore, so you have an error. I cannot even execute this query, yeah? Because I just effectively original discard means that there is only item. I could even skip the choosing, because after original discard there is only an item in each of the documents. So I did a lot of changes, but let's go back. Yeah. So now I'm going to the next command, and I'm trying to extract, like item is actually a single item now, but it's still a string, and I want product ID and quantity to become actual data. So I'm looking into, I'm doing another extraction with a relevant regex that extracts product IP and quantity into item, a key I call item data. And the interesting part in this command is that quantity, I know that it's a number. Effectively, it's just a regular expression extraction, a capture group, but I want quantity to be dealt with as a number. So I'm telling the extraction to convert the data type to a quantity to a number. There is actually a command for it as well. I could do a convert data type to quantity, but extract, because it's very common, has a native support for it. So let's take a look about what actually exists here after this second extraction. And we can see, I'll do another, I'll go to choose item data. Yeah. And as you can see now, I did the choose just for the sake of the example. You can see that item data is actually an object now. And if we look at the raw data, we can actually see that not only it's an object, but quantities actually become a real number, so you can actually deal with it as a number. And that makes it very easy to continue with the group by. I'm saying take extracted.state and do an aggregation that sums the item data.quantity into total quantity, and then I'm ordering by the total quantity in a descending, and then I'm getting the final example as we saw it in the slide. One interesting thing I want to actually show, which is part of the UI, but I think that it provides kind of a sense of the power of DataPrime and Coralogics in that regard, is that this is a query that converted the data in multiple ways without touching the actual raw data. And now there's no choose, so we see the entire object, etc. And if I go to state here, I could do it in the grid itself, of course. If I do go to state here, I remind you that state was actually a string within message originally. It's not really a field. There's no real field called state. But if I do a show graph for key for the state field, then I'm actually getting a group by count of state, even though it's not really in the data itself. It's an actual group by on the result set of everything that I did until this point. Okay, that's an important point, and a lot of the kind of virtualization of the data set, like we were saying the word data set as if it's something familiar or well known, but effectively every query is a data set of its own, even if it's a virtual one. Like in this case, there's no real data being stored anywhere, but you can still continue further analyzing it, and the UX features, like I've shown, are actually treating the result set as a real data set behind the scenes. So this is a first example. Questions on that, short questions before I continue, because it's a lot of context about the example. Okay, I'll continue. example 2, okay? So example 2, here we're taking another string-based, and I'll show it briefly. I won't show the entire example, but I want to show something brief here that would be interesting. You see that effectively the developer wrote a JSON string, the JSON as a string into this message. And there is some aggregation here per currency, the total amount in US dollars. It's related to the enrichment that Eyal has mentioned. So let's take a look at the maybe two points which are important for this example, just to save some time, okay? So this is the final example. Let me show you the query itself, like the data itself, the raw data. So this is the raw data, yeah? And I'll do a choose, just a second. Yeah. So this is like the relevant object that we are, the relevant JSON object. I remind you that this is effectively just a string. So I'm doing something which one person told me I'm crazy, but it's not really crazy. I'm extracting the charge string, the JSON part, into its own field. I invoked with request, and then I'm just extracting the rest of the data until the end of the message into some charge string field. You can see that charge string now is still a string, but it actually contains the JSON. And there is another extraction type in DataPrime, native one, that's called JSON object. And then I'm saying extract charge string into charge data using JSON object. And then you'll see what actually happens. Like the entire string became an object. I can actually even do a choose in order to eliminate the old data. I don't really care. And I could actually even bring it to the top level if I want to, yeah? So now I can actually see the charging data from a string which was very deeply embedded within a log. It just became an actual structured log, which, like I said earlier, if I want a show graph or key for the currency code, then now it will actually work. I can see the number of logs per currency, which is something that was buried very deeply in the log, and now it became feasible to actually do analytics on it, very instant analytics on it. So this is one important point regarding this example. There is an aggregation afterwards. Just for the sake of the recording, I want to say a couple of words on this. The unit and the standard way to provide currency in one of the standard ways to provide accurate currency in a JSON is to provide the units and the nanos of the units. So effectively, it's if it's dollars, then the units is the number of dollars, and the nanos is the fractional part. And this is why the fractional part of the dollars up to a high resolution, not just cents. So the sum here is actually summing the total amount in an accurate manner, not just taking the units, but also the nanos, because they add up for a lot of data. And then I'm referring back to what Eyal has shown you before. He actually used, just for the sake of the example, he used static conversion rates. But you can see here that we have an enrichment that provides the conversion rate to US dollars. I want to actually show, not just show the enrichment, but I actually want to show the actual source of the enrichment. This is actual data that I've uploaded. It's obviously not the real conversion rate. So we have the currency itself as the ID and the field called conversion rate. This is actual data, yeah? Like it's an actual data set that I can count or even filter or whatever. But once we use it for enrichment, it's not an enrichment data set, it's just a data set, yeah? Okay? And it's used in this case for enriching the currency with the information, the matching information from the conversions data set. And from here, you can just treat it as another field. Obviously, I'm creating a total amount in US dollar. I'm normalizing it using the conversion rate. Yeah, I'm ordering by the amount of US dollars, but now if I run it, you will see that it's nice, but like the total amount in US dollars, but it's not really that beautiful, right? Let's do a choose of currency and total amount in US dollar. You can see the auto completion at play here. Yeah. So I can choose the total amount in US dollar, but like I said, it's very dirty. It's like not really easy to read, etc. So I want to do one more thing to show one more example of the power of Coralogics. Like I can divide it by millions. Maybe I'm not seeing well. Yeah, it's like millions, right? Yeah, but that's nice. But that's not also only the only thing I can do to make it look more beautiful. So let's round it to 3 digits, and that's even nicer. But it doesn't really say that it's millions. Okay. So let's say it's millions USD. I'm aliasing the headers, the columns, so you can see the column header actually changing. But I might be able to do something better. DataPrime has string interpolation, like you can provide a string templating, and you use backticks for this, and wrap the actual expression with curly brackets, and then I can add a B afterwards. Sorry, M. Yeah. And now it's a little bit nicer. Maybe when I do that, then the column name should not be millions, but just be US dollars. And now it's nice, but I could actually even add a dollar here in order to actually make it even look a little bit more user-friendly and readable. So this is the second example I wanted to show. A third example, I won't be running it. It's actually based on some sample and dummy data that I've created, but it touches ARRs, etc. So I don't want to actually run it. I have a mistake of actually running it. So I just want to explain it. NPS, I'm not sure if everyone is familiar with it, but NPS is a market research metric that allows to measure customer satisfaction. You do surveys, and each user email is attached to a score. So I've uploaded NPS data into a data set, and what we are trying to do here is to actually connect and enrich the RAM data with per user NPS score, with the NPS scores that they actually gave, and try to find a connection between the customer satisfaction and specific page URLs that this user has actually played in the app. And you can, maybe I can't zoom it, right? I can't zoom. But you can see on the left here, you can see actual page fragments. It's the last part of our page URL. And the number of unique users that actually fill the survey. It's a sample, of course, so it's a very small number. And the number and how many unique companies they were actually from, and the average NPS for a page. It's like you're starting to connect between a product or a business marketing related aspect and a very, very deep technical aspect of the user experience in the actual app. This will change if the pages in the app change over time, yeah, because it's dynamically provided from a real user monitoring solution. And this might be an amazing tool for product managers to tell them these 2 pages need to probably be optimized because the experience of people who were actually focusing on this area of the product were actually dissatisfied for some reason, etc. I wouldn't go into the entire example, of course, there's no time, but you can look at the aggregation analytics function that we are using, distinct count for the unique users and the unique companies, and the average NPS and the average ARR. I removed the average ARR, obviously, because it's still real ARR, even if it's a sample, so I didn't want to take chances, but this is not a native part of the example, the remove ARR, of course. That's it for the examples. A little bit implementation details, our ingestion mechanism, our own distributed real-time job execution system, a huge one actually, generates around 40 million files per day, over 100 terabytes of columnar data. It runs 10 million jobs per day, batch jobs per day actually, compaction jobs, very large-scale system, amazing one technically, by the way. The team has done an amazing job. Storage, like we said, 2-layer storage, internal data stores for our frequent search data, our own data format in the customer object store for monitoring and compliance. This is specifically designed, and we are working on it gradually and continuously to provide interactive data exploration latencies. All my examples, by the way, are on the archive, on the S3. They're not from the frequent search tier. But it's very important to say that the query planner optimizes for minimizing object store access, etc., in order to optimize the speed. The query engine itself is a distributed query engine based on Data Fusion and Ballista Rust libraries. We had a lot of upstream bug fixes and features, and we're doing it all the time. We have execution overflow to lambdas and cloud functions during auto-scaling in order to compensate for the AWS slowness of actually bringing new nodes up, and the bursty nature of query engines requires it. Parallel execution whenever possible. We're executing more than 4 million queries a day. Everything, one last thing, everything is written in Rust. We are 70-30% Rust versus Scala today in CoreLogic. This is something that has changed. We started as being like 3 years ago, we were mostly Scala and Zio shop, and today we have gradually moved, and this is growing to become more and more Rust based, especially in the data pipeline areas and the high performance ones. Okay, so before going to a little bit, a few words on the future, work, I would like to talk a little bit about our people. An entire R&D group spanning 3 continents. DataPrime ingestion is effectively 2 teams, one related to the frequent search and one to the S3. It's 2 very big areas of expertise. DataPrime schema management and tracking is another team. DataPrime API, they do all the interfaces, the parsing, and the business logic around DataPrime, and a team that's dedicated to the actual execution in the query engine itself. I have to say, this is not for you. This is for our own engineers. These are the best people we could ask for, both professionally and personally. A huge thanks to everyone. We are building this gradually and continuously over the years. Amazing work from everyone. Some words about work in progress. People asked about it earlier, and I mentioned it. We are doing extensive work on DataPrime-based alerts. This is obviously a very native complementary feature of the DataPrime engine. DataPrime-based parsing pipelines. Huge and strategic features called data spaces and data sets that allows data organization and isolation, obviously improved query performance as part of a native part of it, data routing, data-driven data routing capabilities like condition-based, like you see in the example here. You could actually even route to a target data set based on the actual data. In this case, it's slow operations dash the service name. I'm referring back to the streaming nature of the data. A streaming nature allows you to actually fan out different data to different data sets in a data-driven manner, like we see here. Granular scope enforcement for data set, like being able to control who sees what. If you have a data set with 1 billion rows and some group of people needs to only look at some of it, then it will be supported, obviously, as part of data sets. Dynamic quota and budget management on top of data sets. Batch uploading of external data for backfills and migrations from other data sources. Being able to write data sets in different data formats and not only in our own. This is very important for next stage processing, like being able to continue processing. Let's say you want to take all your errors, write them to a data set which is JSON gzip in order for your Spark job to actually take it and continue to process it and do whatever you want with it. And periodic execution of queries, appending the results to a data set. This is very similar to other systems as well, a very important feature, being able to do like a daily summary data set and then run a query every day, collecting data for trending and for visualizations over the course of a very, very long amount of time, like even years, without actually re-querying everything from scratch. several other features, virtual field capability, allowing you to define an expression and reuse it across the system, not only inside DataPrime exploration. The business use cases obviously push us very, very gladly towards adding support for decimal data types, which is a must for price and cost base. Regular templates, it's a new feature for reusable patterns, which will effectively replace the need for and the cumbersomeness that you've seen in the queries for regular expressions. Like regular expressions will mostly be not needed. If you are interested about it, let's talk about it separately with standard and customer pattern backs and reusability capability. And last but not least, a very amazing feature that we're working on, sequence detection, the ability to detect patterns of events over time. For example, find a login, then one or more add to cart within 2 minutes, then check out within 3 minutes, then purchase, and all of this per user. This is like an example from the RFC that we've created for the syntax, being able to actually define patterns over time and not inside a single event. This is it. Q&A. The first question I get all the time is, why did we call it DataPrime? So I wrote it here, but any other questions are more than welcome, of course. Yes?
How do you manage data sources for the enrichments?
What are you referring to when you're saying manage? In what aspect? Like,
do I have some place in CoreLogix where I can see all the data sources
that
have been uploaded?
This is part of the datasets feature, like a dataset management page. Today we are exposing enrichment. The infrastructure for datasets is already there. And enrichment are exposed as datasets, like custom enrichments. But the part of the work that's being done now is full-blown data space and dataset management pages that you will be able, as an admin, to see all the existing datasets, metadata on them, the sizes, manage lifecycle, etc. This is part of the design for datasets, obviously. It's like a native part of datasets is the isolation and management capabilities. It's to be able to grow into enterprises which are very big and have a lot of these separate data sources, and be able to actually encapsulate it and grasp it and manage it. It's a native part of the solution. It will come soon.
Thanks.
Yes.
Hi. First of all, it looks amazing, like the capabilities. Just a small question regarding the scale. Assuming that today...
Regarding what, sorry?
The scale.
The
scale, yes. Basically, assuming today I have a large, let's say, data set that it's like X size, tomorrow it will grow to be 10X. The performance it showed was really nice, but do I, as a customer, supposed to expect some kind of lagging or like...
so...
Especially around distinct, you know, when you do like count distinct.
There are two parts to it. Like, obviously, we want to make it as fast as possible, and we're always working on it. And we have, like, I mentioned it on why creating our own analytics engine. A native part of going into that direction is to be able to serve more use cases and scale in a way that will allow us to optimize things, like more indexes, faster indexes, change indexes behind the scene, indexing mechanism depending on the size of the data set, etc. So we're dealing with that all the time. And the idea is to be sublinear. Like 10x data obviously will not mean 10x duration of execution. That would be crazy. Very, very low sublinear. Yeah. And in most of the cases, you can see that. Like you can see that even querying, even today on 7 days, it's like enlarging the data set in a sense. Instead of 1 day or 3 hours, then obviously the times do not multiply. But it depends also on the use case basis. Because as the example I've shown, I've mentioned earlier about daily summaries, in most of the cases for trending dashboards, seeing or comparing the recent day, like a real use case, comparing the recent day to the last year, yeah, like on a per day of the week basis, yeah. This is a very valid and relevant use case. It doesn't make sense to support in the analytics system itself to support querying over a complete year, yeah, every day or every time you want to see the dashboard. It just doesn't make sense because it's a waste, not related to technology, yeah. It's a waste. So The capabilities that we're building on top of this, like being able to append to an existing data set and being able to periodically execute background queries and write the information, would allow in these cases to eliminate the need for that. Yeah? You will just run on the existing daily data, like on the new daily data, and the dry data, the data which doesn't change anymore, you already have the results baked in. For cases where you need an actual new analysis on a year or on 5 months or whatever, or on more data but less time, it doesn't matter. Yeah, this is why exactly the reason that we have background queries capabilities. Like you will not be able to do that in data exploration mode because it doesn't make sense. It's like a heavy query. It's something that's not really needed in real time for debugging production in most of the cases. But it's something you want running, and maybe even if it takes 2 hours, background queries will run and will eventually notify you that it's ready, and you will be able to actually look at the results and then continue the exploration because you will do source background queries dot my results pipe whatever. So it depends on the use case, and the idea is that we are solving it from multiple directions. We cannot do magic on reading 50 petabytes of data like in 1 second. Okay? Yes, more questions.
I think we're good with it.
Yes?
Yeah, some time management, I think we're good. Where we're going now? Okay, so
thank you very much.
Thanks, Ariel.
Thanks a lot.
Guys, we have a nice lunch for you, which will be served here to all the sushi lovers. So thanks for listening.